Example 5. If the given function f of theta is in this form, can I write it in this shape? It is inverse function, but I just put 1/2 for the square root and 1/5 power for here. There is a fifth power for the root, so I'll put 1/5 here. The outermost function here is sine inverse. So first we take the derivative of sine inverse, which equals to this expression. Look, I have done with the sine inverse, which is this. Now I'm gonna play with this part, with this brown part, this one. Look at here, it is the product of two functions. So just apply the product rule here. Put tangent theta to the 1/2 as it is, and take the derivative of this term. So cos cube theta to the 1/5 will be 1/5 into cos cube theta to the whole 1/5 minus 1. And then the derivative of the inner function. So here I'm gonna pick 3. It is like x cube. So derivative of cos 3 theta equals to 3 cos square theta. And then the derivative of cos, which is negative sine theta, plus then the derivative of this tangent theta to the 1/2, which equals to 1/2 into tangent theta to the 1/2 minus 1. And derivative of the inner function, which is tangent theta. Derivative of tangent theta equals to secant square theta. And put the other term as it is. Just apply the chain rule here. This is the given expression, which can be written in this form. Just put 1/2 for the root. This is the fifth root. Just put 1/5 for this root. Remember, don't forget here, if there is 4, you have to put 1/4. If there is 3, you have to put 1/3. First, to take the derivative of the outermost function, which is sine inverse. So derivative of sine inverse is 1/1 minus this stuff. This is the derivative of the outer function, sine inverse. And then once you do with the sine inverse, you ignore it for a moment and then play with this part. Remember, don't take this square now. This square is a part of the outer function, which is sine inverse, not the part of this inner function. You have to play only with the stuff inside the parentheses. When you look at here, it is a product of two functions, one times second one. To apply the product rule here, so according to the product rule, put one function which is tangent theta to the 1/2 as it is, and take the derivative of the second function. So within this function, within this part, the outermost function is 1/5. It is like x to the 1/5. So apply the power rule here. It equals to 1/5 into cos cube theta to the 1/5 minus 1. So once you do with 1/5, you ignore it for a moment. And then play with the second outermost function, which is 3. Remember, not cos theta. 3. Again, it is like x cube. So apply the power rule here. Cos cube theta equals to 3 cos square theta, because 3 minus 1 will be 2. And look, I have done with 1/5 and I have done with 3. Now I'm going to play with the cos theta, which is the innermost function. So derivative of cos theta is negative sine theta. And on the right side, now to take the derivative of this function, which is tangent theta to the 1/2. It is like x to the 1/2. Apply the power rule here. It equals to 1/2 into tangent theta to the 1/2 minus 1. And then times the derivative of the inner function, which is tangent theta. So derivative of tangent theta is secant square theta. And then times, put the other function as it is. Simplify it further, you will have this final expression. Look, there is a whole square here. So this square root for the tangent theta will cancel with this 2, and I will left only with tangent theta. But then there is a fifth root here, which equals to 1/5. This thing can be written as cos cube theta to the whole 1/5. So 1/5 times 2 will be 2/5. That's why I put 2/5 here. That is negative sine theta. Therefore, into negative 3/5, there is 5 here, 3/5. 3 is here, 3 is here, and then cos square theta, and then times cos cube to the negative 4/5, because 1/5 minus 1 is negative 4/5, times tangent theta under the root. That is 1/2, so I can write tangent theta under the root instead of 1/2, plus 1/2 times secant square theta times cos cube theta to the 1/5 times tangent theta to the negative 1/2. Since there is negative 1/2 here, so to make it positive, you can bring it down to the denominator. It is up to you. You can do more simplification here. Look, it is not the final version. You can do further simplification if you want. But for now, this is the derivative of the given expression f of theta.